Good evening, everyone. We'll be joining within 5 minutes, so please be with us.
मुकेश will start. Yeah, you.
शिव जरा अपना स्क्रीन दिखाओ कैसा दिख रहा है और पास कर सको तो कर देना मैडम दिख रहे हाँ सलमान लाइन कर
A very good evening, everyone. Thank you for joining and being with us here today. My name is Mukesh Dubey, and I'm the Senior Program Associate here at upGrad. Before we move forward, and I would like to invite Trapti ma'am to take it forward from here. Before that, I would like to share a few of the instructions with you related to this Zoom platform. Number one, since you are connected through webinar link, so you would not be able to unmute yourself. In order to you want to ask anything or you have something in mind, feel free to use the Q&A section, and you can even reach out to us in the chat section as well. If you are not able to hear our audio, then please make sure you are well connected through login via computer audio option in order to able to hear the audio of the speaker. Without further ado, let me invite Trapti ma'am to take it forward from here. Trapti ma'am, over to you.
Thank you so much, Mukesh. Good evening, everyone. I, Trapti Agarwal, Deputy Dean of Maharishi School of Data Science, would like to take the opportunity to welcome one and all on this wonderful evening to join us on the webinar Data Science and Art of Excellence. I extend my warm welcome to Honorable Chancellor Sir of Maharishi University of Information Technology, Shri Ajay Prakash Srivastava ji. Welcome, sir. I would like to welcome Honorable Vice Chancellor of Maharishi University of Information Technology, Professor Bhanu Pratapji. Welcome, sir. He is logged in with us as one of the panelists. A warm welcome to Director of Maharishi University of Information Technology, Dr. Dinesh Pathakji. We welcome you, sir. Let us start the event with some information about Maharishi University of Information Technology. I would request Dinesh sir to talk about Maharishi Group. Dinesh sir, over to you.
Thank you, Trapti ma'am. Honorable Chancellor sir, Vice Chancellor sir, all panelists and other dignitaries. Maharishi University of Information Technology is one among the foremost well-equipped university counted among the highest technical universities in India, is additionally well known for diffusing quality education to students from lectures and a first program to top-notch college and a installing field replete with the simplest infrastructure, yet as ample and experienced area, there nothing that MIT has left to probability in making certain the comfort of its students, and for this reason, it can be truly considered the one of the best technical universities in India. The Maharishi University of Knowledge Technology is one among the dynamic research-intensive university. Our safe and delightful field is home to our faculties, well known for its college, it as for the innovative courses offered here. The university is technologically well equipped to make sure that students have all the help they have to finish their course. With the proper combination of theory, practical, and active expertise, MIT Lucknow and its Noida campus provides simply the proper learning atmosphere for MITians to pursue totally different courses. That educational exposure that the scholars get here brings them nearer to their goal of building a triple crown career for themselves within the future. His Holiness Maharishi Mahesh Yogi Ji was the first chancellor of the university. Maharishi Ji, a renowned scientist of consciousness, revived the ancient meditative practices from the yoga tradition of India. He brought meditation out of its traditional shroud by mysterious and into the light of science, making it easy for anyone to learn and opening it to the scrutiny of modern medical research. Maharishi Ji helped to establish that the meditative state, pure consciousness, transcendenting, constitutes a fourth state of human consciousness distinct from walking, sleeping, and dreaming. Research has shown that adding a few minutes of transcendenting each day with TM, transcendental meditation, has profound benefits for health and brain function. Thank you very much. Jai Gurudev.
Thank you so much, sir. Now, I would like to give some more information about the technical collaboration that Maharishi University of Information Technology had with upGrad. upGrad offers online programs and also have collaboration with many universities like IIT Madras, IIITB, BITS Pilani, Duke DE, Liverpool John Moores University, and many more. This company has been awarded the title of Best Tech for Education by IAMAI in 2019. Data science is the new science, and data science is an art of excellence. Isn't it obscure? Let's listen and interact with a speaker, Mr. Imaad Mohamed Khan, and demystify data science. Imaad Mohamed Khan is a data scientist, content creator, and an educator. He graduated with a master's in Internet Technologies and Information Systems from TU Braunschweig, Germany, and did his bachelor's in Electronics and Communication from MS Ramaiah Institute of Technology, Bangalore. He is currently a data scientist at Vahan.ai. He runs Mentissa data science meetups and webinars and create videos on YouTube as well. I welcome you, Imaad, on behalf of MUIT family. Now, Imaad, I'll hand over the session to you. Please share your screen.
Thank you, Trapti. Just give me a second. Let me see if I can share my screen. Who can share? I think Mukesh, you will have to stop sharing.
Yes, Imaad, I have stopped sharing the screen.
Okay, yeah, now I can see. Hey, can you see my screen?
Yes.
All right. Thank you so much for the warm introduction, Trapti, and thank you, Maharishi University and upGrad for having me today. It's a real honor and pleasure to be speaking to a panel of such distinguished people and to all the students out there. So today I'll be talking about data science and art of excellence. While I was reflecting on the topic, I was also thinking about data science in general, and what data science is both a science and an art. So there's both of those factors that you need to have to be successful in data science. But today what we're going to do is actually go one step before that and try and see what really is data science and why you should be doing data science. So let me just quickly begin. Like already Trapti gave a brief introduction, I'll just quickly get you up to speed on who am I. I'm a data scientist at Vahan.ai. I'm also a data science educator, LinkedIn content creator, and as you mentioned, I create videos on YouTube which are related to data science, machine learning, and other Python related stuff. Previously, I was co-founder and CTO at Recreate AI. I've worked at Indigene as a data scientist. I did my master's in ITIS from TU Braunschweig, and my bachelor's was in ECE from MS Ramaiah. Okay, now that we have the context out of the way, this is the agenda for today. Today, I'll be talking to you about data science, what, why, and why now. Before that, I'll just introduce you what is data science, machine learning, AI, and what is the difference between all of these. Then I'll take you through types of data used in the industry, the skills you need, the jobs you can apply, and then we'll have some time for questions and answers. I hope I will be able to cover all of this because there's a lot to cover. So without further ado, let me just quickly move on to data science, ML, and AI. And I'm sure most of you have heard of these terms, data science, machine learning, AI, either on TV or print ads or on buses. In fact, in Bangalore, you will find a lot of ads related to data science on buses. So many places, so many different definitions, and I'm here to help you understand what each of them mean. Data science. Now, this is a diagram known as Venn diagram, and I'm sure in your school days, you must have learned a lot about set and set theory. A Venn diagram, basically, wherever you see the intersection is wherever you see overlap is where you take the intersection and say that, hey, this is what is the aggregate. So if you see here, you see a yellow circle, you see a purple circle, and then you see a blue circle. And right in middle is data science. Yellow circle stands for hacking and coding. The purple circle stands for statistics and mathematics, and the blue circle stands for your domain knowledge. In this case, it could be marketing as the domain. So if you put all these three together, it gives you data science, right? So it's an interdisciplinary field which combines skills of different backgrounds. You need to have hacking and coding skills. And if you see the yellow circle, the lines that come out of that, you need to understand the constraints of data, the privacy constraints, the legal constraints of storing data. And this is a very big topic in the European Union. There's in fact laws around that, right? Getting the right data. And in fact, if you remember on WhatsApp, they have been showing up messages asking you to accept certain conditions, right? And this is because privacy and legal matters matter a lot. Getting the right data in data science is a very big challenge, and in fact, it's part of the job. It's one of the most fun part of the job. You being able to recognize what data is needed and going ahead and getting that. And then once you get that, the next stage is data preparation. So how do you go about data wrangling and data munging, changing data from one format to another so that your data is in a very good format that you can use for modeling and other purposes. Data governance, understanding what data you have, what data can you share with other stakeholders in the company, and making sure that everyone who needs to have the access has the access, and who doesn't need to have the access doesn't have the access, right? And overall governing the data as to how it is being accessed in the company. SQL, SQL is a very popular way of querying relational databases. So you have different kinds of databases. SQL is used to get data out or insert or update. So all these different functionalities. So this is the hacking and coding part of data science that you need to know to be successful as a data scientist. But this is not enough, right? You need to know the mathematics side, which is the purple circle, which is your statistical packages, your advanced math, your experimental design, model fitting, and all of that. So you need to have the right mathematical background as well, which is probability, statistics, linear algebra, and calculus. And understanding what you mean by hypothesis testing, understanding how you can run A/B test, understanding how you can build models, different kinds of machine learning models. What is the mathematics behind that? What is the intuition behind each of those methods? Is also important, right? It's not only about you being able to code or write something. It's also about being able to understand the mathematics behind it. Putting that together, you will get predictive analytics using scripting languages like Python. Right, so the Python or R are very popular tools in data science, which allow you to do this, which allow you to use your code and your mathematical knowledge to build stuff. But this is again not enough, right? You have your coding skills, you have your mathematical knowledge, but you oftentimes in any industry you work in a particular domain. So, for example, the company I work is mostly into HR. By HR, I mean mostly into recruiting. There can be companies like upGrad, which are into education. There are companies like Flipkart, or Flipkart is e-commerce, Zomato is food delivery. So you have different kinds of companies working in different domains, right? And oftentimes data in each domain, and there are companies working in the medical field. And my medical field is my most favorite example to give, because the kind of language they use is so obscure. It's something that they usually understand. The people of that community understand it more than anybody else. So the data sets have their own meaning. And if you have substantial expertise in that particular domain, then you become much more valuable as a data scientist there. So that understanding of customers, or defining metrics that matter, or asking good questions, or making it actionable is very important from a domain perspective. So when you bring all these things together, your coding skills, your mathematical understanding, and your domain understanding, then you're able to build something which is really useful to the company and takes the company from 0 to 1, right? So this is basically the essence of data science, right? All of this is put together data science, okay? If you see, like I said, right in the middle, if you see, data science is all of these different fields put together. I hope this was a very good, like sort of an intro into what data science is. But data science is a large field, right? It's not only this. There's something called machine learning. So I explained to you what data science is, but I never mentioned the word machine learning in the previous slide. The technical definition of machine learning is what is written here. A computer program is set to learn from experience E with respect to some class of tasks T and performance measure P, if its performance at tasks in T as measured by P improves with experience E. And this was sort of an older definition given by Tom Mitchell, a professor at Carnegie Mellon University. This was, again, towards the start of the machine learning revolution. But if this sounds confusing to you, don't worry. I'll just give you a very simple example based on this definition, which will make you understand very clearly. A computer program is set to learn from experience E with respect to some class of tasks T. So when we do machine learning, we have some task in mind. We want to make the machine learn, but with respect to certain task, right? We have a task of, say, trying to predict the sales, trying to predict the housing costs, right? Like, let's say there is a house that you want to buy. You don't know the price of a house in that area, but you know the general prices of a few houses in that area, but you don't know the price of this particular house. This is a task that you can use machine learning for, right? So your class of task T is trying to predict the price of the house in this case, and performance measure P. So a computer program is set to learn from experience E with respect to some class of task T and performance measure P. So your class of task T here is your predicting the price of the house. Your performance measure P here is how well do you predict, right? You want to, when you make a prediction, you want to be accurate. So maybe accuracy could be a measure. So in this case, right, does it make sense? So accuracy is a measure of your performance, and that is P. And learn from experience, E, is basically all the data that you have on the other houses. So I already told you, in this area, there are 10 houses. Out of these 5 houses, you already know the pricing and other specifications, like how many rooms are there in the house, what is the area of the house, how many floors are there, right? So you already know that, and that is your data, and that is the experience that you already have. And that is, computer program is learning from this experience E, which is the data that you have on other houses, with respect to some class of task T. Your class of task T, your task here is to predict the price of a new house, which you don't know, and performance measure P. Your performance measure is accuracy. You want to be as accurate as possible. Now, when does when do we call a machine learn? When do we say a machine learns? When its performance at the task T, as measured by P, improves with experience E. So if I increase more data, now I have 5 houses. If I say I have 9 houses data, now my experience increases. Therefore, my performance at the task T, my performance of being able to predict the price of the house should increase. By how? By when I check the accuracy, it should increase. That is measured by P. So this is in simple machine learning, right? You have a task, you have a performance measure, and you have some data, which is your experience. And then you put a combination of all of this. You try and increase the data so that your performance P gets better, so that you are able to do your task better, right? And that is what, in a nutshell, is machine learning. Remember, we already talked about data science, and look at the way the definitions vary, right? So moving on to artificial intelligence, and this is a very wide and very often thrown upon term. Lots of marketing teams use this. Lots of people around the world talk about how AI is coming up and all of that. But if you look at it at a more technical level, right? So what does it mean? The word intelligence is derived from Latin word intelligentia, which is the ability to understand, or intelligere, understanding, right? Artificial intelligence. So the artificial ability to understand, or the artificial ability to understand, understanding artificially. So if an entity possesses cognitive abilities, which is basically ability to reason or understand or abstract and solve problems, apply knowledge and language artificially, then it is known to have artificial intelligence. This is the definition of artificial intelligence in a theoretical way, right? When there is an entity which has ability to reason, understand, abstract and solve problems, apply knowledge and language. And these are all, if you think about it, these are all cognitive abilities that humans possess. You and most of us here have ability to reason, so we can reason through things. If this happens, that takes place, and so on and so forth. Ability to understand, ability to abstract and solve problems. You're able to look at the situation and say, hey, this is where I have to solve this problem. Apply knowledge and language. We're able to communicate intelligently via a language. This is also intelligence, right? We have come up with a uniform framework so that I say something and you understand. So this framework is intelligence at play, right? So all of this put together, if an entity possesses all of this, and if that entity is artificial, then we call artificial intelligence. Now, if you look at all the artificial intelligence that we see today, that in its truest form is narrow AI. So this is the definition of wide AI, which is the ultimate goal of scientists and engineers working towards AI, which is basically an entity that can reason and do all of that on its own. But what we have today is narrow AI, where we define the task in certain domains, and then the machine is really able to perform well in that small subtask, right? But it's not able to generalize to different problem statements. And that is why we say that we have been able to do a lot of inroads in narrow AI, but wide AI is still an unsolved problem. However, in industry, many deep learning methods are referred to as AI today. And as we've seen, AI has a broader definition in general. So this is the way each of these are related. You see the AI circle is the bigger circle, and then you see machine learning as a subset of AI. It's one part of AI, but it's not entirety of AI. And then you have data science, which is part of both machine learning and AI, but it also has this mathematics and statistics, visualization, EDA component that we don't see often with ML and AI. Right? So again, a lot of data analysis and data visualization is baked into data science. right? So this is how all these three are related. And I hope this was a very good introduction to all these different terms. Now, moving on to why data science, right? Now, for the sake of the rest of the talk, we'll just talk about data science because we want to understand how it really works in industry and what do people actually do. But before we do that, we should understand why data science and why is it really taking off now, right? Why is data science as a field becomes so pervasive, and why is it being adopted by so many folks? So for that, let me take you back a little bit to the reason, right? So if you look at this graph talks about how data is being generated every single minute of the day in the year 2020. But again, this is in fact perhaps more now. So for example, if you see Microsoft Teams, there are about 52,083 users connected. If you see on the top left, WhatsApp users share 41,666,667 messages per minute. There are 147,000 photos being shared somewhere. There are about 1.38 million people making video or voice calls in a minute. The amount of data being generated in a single minute is massive. Just look at these numbers, right? This is just a minute in 2020. Just 1 minute, and all of this is happening. And the scale of data is unimaginably high. And this is why data, and data never sleeps, like I mentioned, right? Like data is being generated even as you sleep. The amount of data that we have now is massive already. And this is only going to keep increasing. This is like, it's massive already. You saw all the numbers, but it's not going to stop there. It's going to keep increasing according to this annual size of the global data sphere by IDC's Data Age 2025 study. Just look at the data increase. It's an exponential increase. The number of zettabytes we're going to be using in 2025 is close to 160, right? And today, if you look at this estimate, we are at 2021, we are about 60. So we are almost going to go more than 2 times, which is massive, given that already we are at a massive scale, right? Data is already massive. So much data is being generated, and this data is only going to keep increasing. And what happens when you have so much data? Organizations start realizing that, hey, there is so much data that we could perhaps make use of. And AI adoption is increasing in organizations. This is a small article from Gartner Hype Cycle, and they talk about how AI is reaching organizations in many different ways. I'll just read the first paragraph and then move on. Between 2018 and 2019, organizations that have deployed AI grew from 4% to 14%, according to Gartner's 2019 CIO Agenda Survey. So organizations are realizing the value of using AI, right? AI depends on data. So basically using of data is deploying AI. Organizations are growing from 4% to 14%. So organizations are seeing growth by adopting AI. And this is being seen in many different forms. So there's something called conversational AI, which is basically the chatbots that you talk to. There's Amazon Alexa, there's Google Assistant. There's so much innovation that is happening in this field, right? There's many new technologies like augmented intelligence, edge AI, data labeling, and explainable AI. All of this is taking form. All of these there are companies being built around all of these. So this is a massive revolution that is taking place, and this has been happening since the last 3, 4, 5 years now already, right? So this is the way the trends are going. So we saw data is increasing. We saw data will increase further, and organizations are adopting more and more AI in their companies so that they can benefit from that. But what happens as a result of all of this, right? Because there's so much data being generated, and because organizations can get value extracted, but who is going to do this, right? There should be somebody who can sit and do this. And that has led to an increase in jobs. And this is only one example. This is an older screenshot where I just went and searched for data scientists in India, and I got about 3,000 results for only the data scientist position, right? And now it must have even increased even further. So the opportunity in the field is only going to increase because, as you see, the data is going to increase, and then the jobs are also going to increase. So this is why data science is taking off. This is why jobs are taking off, right? Like, why data science? Why does it even make sense today that all of this is happening? So I hope I was able to convey that message to you. Now I'll move on slightly towards more application-oriented stuff towards more practical stuff. Again, this is going to be very quick introduction into the types of data used in the industry. Because we've already seen the motivation as to why data science is important, but let me just quickly take you through the types of data used in the industry and how you can go ahead and benefit from that. So these are different data formats used in the industry. There's tabular data, images data, videos data, text data, audio data. When I say tabular data is in the form of rows and columns. So there are different rows and there are different columns. Example, data in an Excel sheet. Image data is stored as a 3-layer RGB matrix. In general, if you talk about images on computers, right? Images are stored as by putting together different layers of colors. So there's red, green, blue, and there are different values for each of them. So that together stores an image. And videos are made up of multiple image frames. So videos in general, the way we see videos is basically a deception of the eyes, right? There's no real movement, but it's just all these different image frames put together and made to move quickly. So videos are made up of different images. Text data, you understand what is text data. I don't need to tell. If you're able to read this, you're able to see text data. Audio data can include human speech, music, different sounds, etc. So these are the different kinds of data sets used in the industry. I'll just quickly take you through a few applications of each of these. Tabular data, can somebody just tell me if I have 10 minutes left, right? I don't know how much time I have, but just give me a reminder if I have 10 minutes left. Okay. Tabular data. So what is one kind of application of tabular? So this is what, if you see on the on your screen, this is how tabular data looks. You have different columns and you have different rows. And you use this tabular data to perform different kinds of applications. I will not get into the specifics because it will take time as to what is this example and stuff. But I'll just say that this data set that you see is useful to be able to classify if cancer is present or not. And that is the first point I have mentioned there. And this is the exact data set that you can use. I'm not going to go through that data set, but this is the exact data set. So if you want to be able to predict if cancer is present or not, this is a good use of a tabular data set, use case of a tabular data set. And then basically when I say classification, I mean you can put it into different categories, right? Cancer is present or not present. Or maybe you can say, is this guy passing my criteria or not? If it's an automatic system for classifying, okay, let me give this example, right? You have, many of us here have used emails. Many of us have email IDs. We have different categories of tabs, right? We have inbox, we have promotions, we have social, we have spam, which is one of the most famous examples, right? So spam or not spam is another example of classification. So you either put it into spam or you don't put it into spam. So that is classification. Regression means trying to predict a continuous value, which is what we discussed earlier, right? I talked about, I want to predict the price of the house, given that I know how many rooms are there, I know how many people are there in the area, all the different categories. So regression means I'm able to predict the price. It's a continuous value prediction rather than a different class. Another example of regression would be predicting the sales of a company, right? If you think about all the different, if your boss comes to you and says, hey, can you tell me next month how much sales are we going to make? Then you go ahead and build a regression model. Recommendation systems are everywhere. If you've ever interacted on the internet with any e-commerce website or OTT platform, you would have seen a recommendation system, right? Your Netflix, Amazon, YouTube, all of these have recommendation systems working behind the scenes. You have your Flipkart, Amazon, again, and Snapdeal or any other e-commerce website. All of these have things like people who bought this also bought, or similar items and all of that. So these are all recommender systems working behind the scenes. So all of this uses a tabular data set behind the scenes. Images and video data set, different kinds of examples. This is, again, one project that I did and put it up on my LinkedIn a year back or a year and a half. I'm not going to talk about this project, but again, different kinds of applications. Image classification, right? If I give you an image, can you tell me if this image is of a dog or of a cat or of anything else? So, and cats and dogs are very famous in the image classification world, and that's why I'm giving this example. But you can also use to say if it's a chair or if it's a table, anything. If you want to show the image to the computer and then tell the computer, can you tell me what is this about? Object detection is looking at that image and being able to identify different objects in that image. So if I give you an image of, say, the room of your house, can you say this is the pillow, this is the bed, this is the blanket? So all of that, right? So that is object detection. Face recognition is what you see here. If you see that image, the computer is able to say that this is Mahatma Gandhi. And that is basically, it looks at the face, identifies different key points on the face, and then is able to recognize if that person is that person that we already know or not. And I had built the system as an Independence Day project. Pose estimation is another very interesting idea where you can go ahead and estimate the pose of a person, right? Like if you see me sitting right now, you can estimate the different points on my body. And then if I move my hand, you can also see the movement of my hand from pose A to pose B, or location A to location B. So this also has a lot of applications, like there are fitness apps being built, right? Like people want to be able to determine if the pose of their body while doing that exercise is it correct or not. So things like that are being built actually right now. So this is again image and video data. Whatever you do for image, you can also do for video by breaking it down into different frames, right? So this is in brief different applications of image and video data in the industry. And there are a lot more applications that I'm not covering here, but that is in brief. Text data, again, this is a project that I had done where I was trying to predict if an incoming email is a rejection for a job application or a not reject. Right? I already told you there is this concept in emails that when somebody sends you an email, you try to say if it's a spam email or not a spam email, right? And then all of you have spam folders in your email addresses. This, based on the same concept, I tried to build this application where you send an email and then I'm trying to say if this email is a rejection or not rejection. And in fact, this was a very popular project. I have written about it in my Medium blog as well. And a lot of people in the LinkedIn community actually enjoyed reading this. And in fact, a few even approached me for interviews after this post, right? How ironical, but this happened. Second is named entity recognition. And to explain that very simply, if you read the example, it says Delhi is the capital of India. And Delhi is in bold, India is in bold. So if I tell my system, tell my machine to be able to identify named entities, which is basically, in this case, a place. So if I tell my system, train my system to be able to identify places, it will identify the locations of the places and tell me that, hey, Delhi is here, India is here, these are places. So this is the named entity recognition. And this is all of this is happening on text data. Text data is basically data in the form of characters or letters that we see. Topic extraction, very interesting application where you have different documents. So I have document A, document B, document C, document D, and so on and so forth. I give all of these documents to the computer, to the system, and the system will tell me what topic is going on in all of these documents. And it, in fact, tells me the different ratios of each topic. So maybe document A is talking about 30% about fruits, 40% about vegetables, and maybe 30% about cars. And document B is 80% about cars, 20% about fruits. So it gives me these different ratios in which topics are being talked about. I mean, when I say topics, I'm not going to go into much technical details, but I'll just say this because it's going on. Topics, when I say topic, it means the words that occur the most in that topic. Okay, so that is topic extraction. Document similarity, very interesting, leads to a lot of applications. Document similarity is if I give you document A and document B, tell me how similar these two documents are. What is the percentage match? What is the percentage similarity? So this is also something that you can build models for and try and find out. This is a very useful application for, say, a university like Maharishi, where you have different homework assignments or different assignments that you give. You want to see if two students have copied or not, like a plagiarism checker. So you can use a document similarity system to say that, hey, A and B are matching a lot. I think this is suspicious. And then you can go and talk. I hope that doesn't happen here, but just an application of document similarity. Okay, audio data, speech recognition. This I think some of us must have interacted with Google Assistant on our phones, on our TVs, where Google Assistant talks to us. This is an example of audio data where your speech is being converted into text and then being processed. And this is how a lot of these applications are built, where when you talk to these things, right? If you talk to Amazon Alexa, Amazon Echo Dot, or even Google Home, the way it happens is they capture your speech and then convert that to text. And that is called automatic speech recognition, or ASR. And then that text is being processed like how you would do it in textual data, right? So and also I would like to briefly mention, this is called computer vision. This field is called computer vision, and there are a lot of positions in this area. This field is called NLP as well, natural language processing, and there are a lot of like jobs in these areas as well. Moving on to audio data, the second point here is voice recognition. When there is a speaker speaking, you want to be able to recognize that person's voice. So let's say you have a clip of Amitabh Bachchan speaking, and you want to be able to give that to the computer, and the computer should say, "This is Amitabh Bachchan." Right? That is what voice recognition means. TTS, or text to speech. Whenever Google Assistant replies to you, right, it converts the text to speech. So you hear the speech, but that is Google Assistant just reading the text. And there are different kinds of TTS systems at play. Google Assistant, Alexa, all of these use TTS systems behind the scenes. Another very new application of audio data is voice synthesis. So again, let me give Amitabh Bachchan's example. Now everybody can't speak like Amitabh Bachchan, but let's say you want to or rather you want to hear more things in his voice. So you can build a voice synthesis system based on all the previous clips of Amitabh Bachchan. You take his previous audio data and build a voice synthesis system, and then you just type in text, and that output voice will be in Amitabh Bachchan's voice based on your text. So you can basically say anything you want in Amitabh Bachchan's voice based on the text you give to your model. Very interesting application. There are a few companies that are actually trying this out. So this is how audio data is placed. And this is the different kinds of data sets. We've already seen tabular, we've seen image, we've seen video, we've seen text, and this is audio. Skills you need. This is a very interesting topic for students specifically, where I'll take you through a job posting. And this is a very popular company called Urban Clap. Now it's become Urban Company, but earlier it was Urban Clap, where they used to, or rather they get people like plumbers or carpenters or other service workers, and they aggregate them, and then they help consumers find such services, right? So this is the platform that does that. I'll just quickly take you the first part. I'm not going to go through the job responsibilities, but I'm going to just take you through the first paragraph there, because I want to show you how problems in industry are, and how a company like Urban Company or Urban Clap has these kinds of problems. The first kind of problem is key data problems we are solving, matching the right professional for each customer request. So they have a problem of matchmaking. They have different customers, they have different professionals. How do we match these? So this is a kind of problem that data science helps solve for them. Quantifying how many requests were lost based on drop-in conversion due to unavailable slots. Use this data for onboarding providers at hyperlocal level, capacity planning. So what happens is and this happened with me also, when I was trying to book someone on the platform, I was not able to get to that person because there was no slot available. And I was not able to go ahead and book because, yeah, there's no one available, and I had to look for alternate options. So this is a problem for a company like Urban Company, right? They want to get as many requests as possible, but they are also restrained by the service providers that are available. So how can we find out the right place and the right time when there is a lot of demand? So supply and demand matching, basically trying to figure out when is there a lot of demand and when is there a lot of supply available, and where do we redirect the supply and demand. So this is a problem that is again solved by using data science. Using various signals to find out fraud or disintermediation on the platform, fraud detection. And fraud happens on a lot of different platforms. And this is a big problem for companies, right? So people try and figure out different signals that fraudsters leave on the platform. And this is again like a sort of a detective job for you, where you have to figure out those signals, look at the data of users that are doing fraud, users that are not doing fraud. Are there differences between those patterns? And very interesting data science application. Then you have customer segmentation. You have different kinds of customers. You want to understand who are the customers that pay you a lot, who are the customers that pay you less, which areas are they coming from, what are their backgrounds, and so on and so forth. Not taking those requests where we have predicted no partner is going to respond. And this is a unique problem to urban company. Like if there are certain areas where partners don't want to go, or certain localities where partners have been staying away from, how do you identify and how do you find people who will go there? And stopping bad customer experience. So customer experience is another use case here. Identifying providers who are going to get churned and trying to retain them. So all the service partners, not all of them are equal. Some of them are more interested, some of them are less interested. So how do you find which one is going to go away from the platform? How do you find more users to come to your platform? So partner retention. So all these kind of problems are problems of data science. And this is the role, right? This is the role of a data scientist, is to be able to work in not all of these, but one or some of these. Right? I'm not going to go into the depth of the responsibilities, but I just wanted to take you through the kinds of problems that exist in the industry. And these are the kinds of problems that you will solve. And not all of this is science. And that's why the topic data science, art of excellence also sort of makes sense here, because you need to have that understanding of that domain. And that comes by repeated exposure to the domain, by talking to domain experts, by understanding the customers really well. So that brings in that art part of data science. Of course, you have experimentation, you have results, you have your hypothesis building, and all of that, which is the science part of data science. But then you also have this domain knowledge side, which is the art part of data science. Okay, now I've come to the last part of my presentation, which is basically the jobs you can apply in data science. What I see in the industry in general is that data science industry has multiple roles. It's not just one data scientist role. You have different kinds of roles that you can apply for and then enter the industry. If you want to move towards the data scientist role, well and good, but then you can also work with data in any of these different roles, right? One is the business analyst role, where basically you're trying to understand the key business objectives or new initiatives that you can take by looking at the data and then identifying and then discussing with the team and taking action on those business initiatives. So business analyst is doing all of that by using the data that is being generated. Data analyst is the technical side of these things, where the data analyst tries to understand the business a little bit, but then he or she has more skills on says SQL or a little bit of R and Python, where they perhaps do a little bit of dashboarding, where they look at data and do some sort of data analysis on, again, all these different fields that we saw earlier, right? So more of a data analyst role. Data engineer, what they do is they build the different pipelines that the system needs, or rather that the data scientist and the stakeholders need to be able to perform their functions. And this is a very important role in the industry, right? Data engineer, and without data engineer, how do you even have your data to process, right? So data engineer makes sure that the pipeline exists so that your data comes from here, aggregates data from multiple sources, and allows you to be able to use that data at the end of the thing. And this is, and a lot of people are scared of data scientists because of the math part that is involved there. And I understand it's not everyone's cup of tea, but if you still want to be in the data industry and want to work as a want to work in the industry without a lot of math involved, data engineer is the field for you, because there you have a lot of pipeline building, a lot of engineering tasks that are very interesting. So data engineer is the job role if you're interested in less math. Machine learning engineer is basically tries to build machine learning models and then goes and puts them in production, monitors them, and all of that. So basically handles the machine learning side of things. I mean, the data engineer handles the getting the data side of things. After you get the data, you take the data, you build the models out of it, and then you deploy that in production, monitor it in production, and then build this feedback loop where you're continuously improving your models. You're trying to find the best model there. Research engineer, this is a little bit more advanced position where you're trying to do research into different machine learning techniques. You're trying to find out what techniques work, what techniques don't work. And a lot of these roles are found in companies like Facebook, Google, Apple, where you're doing fundamental research and trying to come up with new stuff, right? Maybe you're trying to work on a new way of building deep neural networks, right, or something like that. So the research engineer is fundamentally, and it requires you to have a higher level of education, typically a PhD, So that is the kind of role a research engineer does. Data visualization engineer, these were earlier called BI analyst or BI engineers, or yeah, business intelligence, right? So you can also call them that. You can also call them data visualization engineer. These folks are responsible for building reports, dashboards, and all of those things in the company. And this is, mind you, this is not a simple job. This is a lot. This has a lot of complications and it's a lot of DAX programming in the case of Power BI, Tableau related programs. So there are different tools that are part of the industry, and then you have to do a lot of data visualization building. And data scientist, which is basically 1 plus 2 plus 3 plus 4 plus 5 plus 6 equal to 7, where you have to understand the business, you have to do the data analysis, you have to build the pipeline sometimes, you have to build models, you have to perhaps in some cases go read research papers and implement those research papers if required, if nothing is available. So you do research engineers work, you also build reports and dashboards and front end, so some sort of a front-end engineer's work as well. So you put all of these roles together as a data scientist at half the cost. No, I'm just kidding. So data scientist, yes, he has a lot of different responsibilities. Like I mentioned, it is sort of amalgamation of 1, 2, 3, 4, 5, 6. But data scientist sort of performs the end-to-end function. Okay. With that, I come to the end of my presentation. Thank you so much for having me. I am open to questions.
Thank you, Imaad, for such an insight about data science. Now, to be a data scientist or to be a very good professional in life, you need to ask questions. Basically, you need to ask good questions. So students or the members who have joined or attendees, if you have any queries, any questions, please feel free to ask. Please write it down on the QA box and please write it down on the chat window, wherever you feel like, wherever it is comfortable for you, and we'll take it up for you guys. Right now, I have got one particular question from Jaipreet Singh Baby. It's from you, Imaad. Sir,
Okay.
on what key factors the documents are said to be similar?
Okay, so now you can build this in different ways, right? You can, of course, define the criteria that you want to use to say if documents are similar. Say maybe if you say greater than 70% of the words in both of these documents are same, then I'm going to call it similar. So that could be one criteria you define. Or you could train a model which looks at both of these documents and says that, or like when you give these two documents and then you have a label which says same or duplicate, same or duplicate. So based on that, the model will come up with different key factors that it identifies as reasons for documents to be similar or not. So it could be manually defined by you, or it could be machine learned, and that's where machine learning comes in, right? Machine learns the key factors by looking at the data set. So it could be either of those.
Yeah, thank you, Imaad. I hope it solved the questions, but I have few more questions in the pipeline for you.
Sure.
One question that has been asked like very frequently, data is the new oil. Now, if data is the new oil, then how are companies prepared to handle the bulk of oil now?
Absolutely. So it's a very important question, and I think the way companies are not prepared right now, to be honest. So companies are trying to prepare. They are trying different stuff. The tooling around machine learning and data science is still in its early stages, right? It's not as well developed as, say, software engineering. So I think there's a lot of innovation and research that will take place. There's a lot of standardization that will happen, which is yet to happen. It has started to happen in some areas. Like, for example, now people are talking more about ML ops, machine learning in production, and how do you actually use machine learning models to get business insights. So now people are not just like, hire a data scientist, let him do whatever he wants. Now they're asking questions of how are you going to get business value. So that is, I think, very good sign for the industry. Like, you want to extract business insights, you want to take it to the next level, and this is starting to happen now. And I think companies are going to get more and more oriented towards the ROI, like what is going to come out of that investment. So that's how it's going to move.
Imaad, one more question for you in the pipeline. What is the difference between data science and data analysis?
So that's the difference between the data scientist role and data analyst role. Data scientist role typically involves model building, and data analyst role doesn't really involve model building. I mean, of course, they might build smaller models, and maybe most of them are statistical in nature rather than machine learning based. So data scientist is expected to understand machine learning concepts, whereas data analyst is not. Data analysis, I mean, data scientists should know how to do data analysis. That is a given. But if you can't, I mean, if you can't do that, you can't even do machine learning, because you need EDA, which is exploratory data analysis, as the first step of building a model, right? So data scientist should be able to do data analysis and model building, and data analyst would be perhaps only on the data analysis side.
There's one more question from Ayush Avasthi. So nowadays, which industry is best for us, machine learning or data science?
This is, I mean, like I said, right, data scientist involves you to do.
Question for you, Imaad. It has put you.
Sorry,
I'm saying that it is a tricky question for you that has been popped up. Which is the company which is best for data science and the machine learning?
No, so the way I see it is that they are not independent. Both of them are dependent. Data scientist almost always uses machine learning, so I don't see a lot of difference there, to be honest. But I think data scientist as a role is quite generic, and it could mean different things for different people. Like I said, right, there is text data, there is video data, and text data sometimes is called NLP data scientist. Video data sometimes is called computer vision data scientist. And all of these use machine learning behind the scenes. So it's not like they don't use machine learning. So I don't see it as two separate things. I see it as both one.
Right. I hope Ayush, Jaypreet sir has answered all your questions. There was one more question from Rizwan, and he was asking whether I would be learning all these things if I take admission in MUIT. Rizwan, for you, the answer is yes. You will learn all the technologies that had been discussed and that has been told by Imaad in this particular session. We are teaching everything in MUIT. Thank you so much, Imaad. Now I would request Honorable Chancellor sir to please empower us with your views on this.
Mr. Khan, it was very interesting to hear your presentation, and I was able to learn a lot of things about data science today. I'm a very old student of computer science. More than 40 years ago, I learned computers, and today it has evolved so much, and it's very nice to hear from you. What you said in the beginning, that it's a science and art. So that's what oh, sorry. So what I feel is that this is art from the point of view, because you take billions and trillions of bytes of data, and then you convert into useful form so that a company can use it for their benefit, for their business. So that is actually an art, I would say, rather than science. You use scientific method, but it's an art. So you are absolutely right, Mr. Khan, when you said it's a science and art both. And I think what our students today learn would be useful for them. The various prospects you suggested about data science, the way you explained them, useful for them. And I'm very happy that I was able to spend time and hear you out. And I hope some other time when you are available, when you are giving your presentation, I would come and attend your presentation at that time also, sir. I have a fun question for you. A lot of people ask technical question. I have a fun question for you. And the fun question is that we see a lot of Hollywood movie when artificial intelligence takes over human being. Is that really possible or not? As a scientist, you tell me.
Okay, first I'll answer the second part. I'm not a scientist. I mean, data science, people say it's a science, but I don't, like you said, it's art, science, all of that combined together. So not scientist, the true definition of scientist. But now on coming to the other side, there's a lot of talk in the industry itself, right? Like there are two sides. One is the Elon Musk side, and I'm sure you must have heard of Elon Musk. And the other side is Mark Zuckerberg side, which says, so one of them says that AI is going to kill us. AI is going to, like the way you were mentioning, right? Hollywood movies show us the Terminator side of AI. So one of them says AI is going to be that, which is basically Elon Musk's side. The Zuckerberg side, Mark Zuckerberg is the CEO of Facebook. For those who don't know, so he says that AI is going to be beneficial. AI is going to allow us to improve our productivity, take us to the next level of the way we work. So there are two sides, and there's like the industry is divided on both sides. I'm on the Zuckerberg side on this one, even though I'm not a Zuckerberg fan in general, but I'm on the Zuckerberg side this one. So I don't see that happening. Like I mentioned, right, there are two kinds of AI, which is the narrow AI and wide AI. Narrow AI is AI being really good at a particular task. So, I mean, that is happening today, and that will keep improving. But wide AI is basically an entity which can do everything, which can be reasonable, which can be conscious. I don't see that happening, at least in my lifetime.
Okay, thank you very much, Mr. Khan.
Thank you so much, sir. Now, I would request Honorable Vice Chancellor, sir, to present his views on this.
Honorable Chancellor, sir, Shri Dinesh Pathak ji, Dean Data Science, Mr. Tripti Agrawal, our guest speaker, Mr. Imaad Mohamed Khan ji, data scientist from Vahan Inc, and dear participants, I thank all of you for being a part of this webinar and congratulate all the concerned member of School of Data Science for organizing such an informative webinar. I humbly thankful Honorable Chancellor sir for taking out time and showing his blessing in this webinar. I also thank Shri Dinesh Pathak ji for always being actively working for organizing such kind of activities in coordination with the different school of the university. I also thank Mr. Imaad Mohamed Khan ji for sharing his views and experience with all participants in the field of data science. I also thank Maharishi School of Data Science and upGrad team for organizing such a wonderful session. Thank you once again. Jai Gurudev.
Thank you so much, sir. And thank you all the panelists, all the attendees to spend 1 hour with us on this wonderful evening. Thank you, everyone, and have a great evening ahead and good night.
Thank you,
Jai Gurudev, sir.
Jai Gurudev.
Thank you, everyone.